if we think about how the brain works in modules. I would call them modules. Here's the brain. Here's the brain stem. And a module is like a little section that does something. And I call this a module, but the newest brain science is calling it the connectome. So you have brain cells that are connected together to do one specific task. And I drew a brain module right here because this is kind of the area for auditory processing. And you have different modules that do different things. One module in this area, I'll draw different little colored squares. One module might be very specific to discern a human voice. So you have a cluster of brain cells that only does that one thing. Then you have another cluster of brain cells, also has a very specialized task, and it could be male versus female. You have another cluster of brain cells that does a very specific task, and it could be external versus internal. And so to hear a human voice, we first hear the sound, and your brain's like, is that a dog barking? Is that a cat meowing? No, that's a human talking. And then your brain sends that signal on down the road to another module that says, is that a male voice or is it a female voice? And this happens very early on because babies tend to cue into their mom's voice. And then at a very, very young age, this module develops, which determines that there is an external versus internal voice. And there's a moment, a crucial moment in a baby's life, and this happens very young age, like 1 year old, where that baby realizes that mom is talking to someone. Mom is talking to someone. And then there's this watershed moment where that baby realizes, mom is talking to me. That doesn't happen right after birth. We believe that a baby still thinks they are part of their mom until that point in time when their brain has developed enough to realize there's an external voice that is not me. So mom is not me. That makes sense? And so that's literally one of the modules in here, the not me module. That's all taking place about right here in your temporal lobe, because that's where auditory processing is taking place. So imagine, if you will, a 19-year-old who just finally has moved out of the house and is enrolled at the university and moved into the dorms. That's a fairly stressful time in anybody's life when you first move out of the house and you're making it on your own. So stress seems to be implicated in inflammation, which can cause too much pruning. So often with schizophrenia, we see some symptoms that one of these modules has been pruned inappropriately. We accidentally got rid of one of these things. And so a prodromal phase, we call it prodromal, which is when somebody is working on developing schizophrenia, but they haven't transitioned into full-blown psychosis yet. But they're having prodromal pre-psychotic symptoms. And often it will be things like, I thought I heard a voice. But then they're able to say, no, nobody's here but me. But then as the pruning gets a little out of control, goes haywire, they might completely prune this module. And that's actually what we think is the root cause of an AVH, which is auditory voice hallucinations. And it's a hallmark symptom of schizophrenia. Not everybody with schizophrenia has this, but up to 80% of people do. But they can have all kinds of other strange pre-psychotic or psychotic symptoms, which now that our functional MRIs are getting much more fine-tuned, we can see exactly which connectome got destroyed inadvertently.